In planetary motions, it's Siddhanta Shiromani. Bhaskar second discussed planetary motions in the sections called Graghantika, which consists of 451 verses. Some of the key points he made out planetary motions include instantaneous speeds of planets, approximations of planet motions, including at their highest point. The idea that at its highest point, a planet's instantaneous speed is zero. So, what are the observations of planetary motions? In the Siddhanta Shiromani, Bhaskara second discussed planetary motions in the sections called Graghantika. So it is all about the planetary motions, which includes the idea that is the highest point. A planet instantaneous speed is zero. Bhaskara second considered the instantaneous speeds of planets. So he arrived at the approximations that sin w pi by 4 1 minus cos x slash is sine x. So it's close to notation since w to pi 4 or cross 1 minus cos x. So he started that at its highest point. A planet instantaneous speed is zero. So, what is the meaning of retrograde motions? Bhaskara second Siddhanta Shivamani also explains retrograde motions, a key concept in ancient astronomy. Retrograde motions refer to the apparent backward movement of planet in the sky, which occurs the Earth passes a planet in its orbit. It also explained retrograde motions as an optical illusions caused by the Earth's motions around the Sun. He developed a mathematical model to predict retrograde motions using his understanding of planetary orbits and epicycles. So, some key points about the retrograde motions in the Siddhanta Shrimani, which includes recognitions of retrograde motions as an apparent phenomenon, explanations of retrograde motion as a result of Earth motion, mathematical models to predict retrograde motions, and use of epicycles to explain planetary motions and retrograde motion. Accurate predictions of retrograde motions for various planets, and Bhaskara's second on the retrograde motions demonstrate his deep understanding of celestial mechanics and his ability to develop accurate mathematical model to explain complex astronomical phenomena. So, what do you understand by geometric model for calculating planetary positions? So, Bhaskar second and Siddhanta Shrimani present a geometrical model for calculating planetary positions, which is based on the following key concept: epicycle. Its planets move in a smaller circle, epicycle around larger circle different. What is difference means a large a cycle that represent the planet's average orbit around the sun. Epicycle centers, the center of the epicycles which move along the different planetary position. The position of the planet is calculated by combining the motions of the epicycle center and the motion of the planet on the epicycle. And it also used for the geometrical model to develop a system of astronomical tables which allowed him to predict planetary positions with remarkable accuracy. His model was based on the following some steps, which calculates the mean position of the planet, means every position over a given period. Calculate the epicycle center's positions, and it's also calculate the planet's position on the epicycle. It's combined two positions to get the true position of the planet. So this geometrical model was a scientific achievement along with the predict planetary positions with an error of less than 1 degree, which was remarkable for his time. His work for on planetary motions and geometrical models has a lasting impact on Indian astronomy and influenced later astronomers, including Copernicus and Kepler. So, what do you understand by mathematical concept in Siddhanta Shrimani? So, Bhaskacharya, Siddhanta Shrimani is a comprehensive mathematical and astronomical treatise that covers various branches of mathematics and astronomy. Here are detailed explanations which I'm going to discuss about mathematical concept in this test. So now we're just going to understand about arithmetic. So definition of arithmetic is Bhaskacharya defines that the various arithmetic terms such as numbers, fractions, and decimals. He also explained the different types of arithmetical terms which includes integers, fractions, decimals. Interest computations means he provide methods for calculating interest on loans or investments. Arithmetical and the geometrical progressions, he explained the concept of arithmetical and geometrical possessions, including the sum of series and calculation of mean. Plane geometry, he covers the various topic in the plane geometry, which includes the calculation of area and the perimeters of triangle, quadrilaterals, and the polygons. Solid geometry, he discussed the calculation of volumes and surfaces area of various solid shapes, which includes the spheres, cylindricals, and cones. The shadow of the gnomon, he explained how to calculate the length of the shadow of the gnomon, means a vertical stick or pillar, at different times of the day. Methods to solve the intermediate equations, means he provides the methods for solving intermediate equations, including the use of algebraic methods and the method of continued fraction. Combinations, he explained the concept of combinations and provides the method for calculating the number of combinations of different objects. Algebra, solution of quadratic and quadratic intermediate equations. Bhaskacharya provides the methods for solving quadratic and cubic and the quadratic intermediate equations, which including the use of algebraic methods and the method of continued fractions. Then trigonometry. See, there is a sine table. He provided a sine table for calculating the sine values of the different angles. Relationship between trigonometric functions. He explained the relationship between the different trigonometric functions, including sine, cos, tangent, etc. Spherical trigonometry. So he discussed the application of trigonometry to spherical triangles, which includes the calculation of the sides and angles. Calculus. He also primary concept of the infinitesimal calculus, and it introduced the concept of infinitesimal calculus, which includes the concept of limits and the infinite quantities. Mathematical analysis. He provides method for the mathematical analysis, including the use of algebraic and geometric method. Results in trigonometry. He applies calculus to trigonometry, including the calculations of trigonometric functions and their inverse. Differential calculus. He develops the concept of differential calculus, including the calculation of diversities and the differentials. Integral calculus. He develops the concept of integral calculus, including the calculations of integral and area under curves. Astrology. In astrology, the mean longitude of the planet, he provides methods for calculating the mean longitude of the planet. True longitude of the planet, means he explained how to calculate the true longitudes of the planet, taking into the account the equipotals and the orbit. Diurnal rotations. He discussed the diurnal rotations of the Earth and its effect on the astronomical observations. Synergies. So he explained the concept of synergies, including the alignment of the planet and sun. Lunar eclipse. He provided the method for predicting lunar eclipse. Solar eclipse. He provided method for predicting solar eclipse. Latitudes of the planets. He explained how to calculate the latitude of the planet. Sunrise equations. He provides the method for calculating the time of the sunrise and sunset. The moon's crescents, he explains how to calculate the shape and size of the moon's crescents. Conjunctions of the planet with each other. He provides methods for predicting conjunctions of the planet with each other. Conjunctions of the planet with the fixed stars. He provides methods for predicting conjunctions of the planet with the fixed star. The path of the sun. He explained how to calculate the path of the sun in the sky. Overall, Siddhanta Shrimani is the comprehensive treatise that covers various branches of mathematics and astronomy. and it provides a detailed explanations of various mathematical concepts and their applications to astronomy, making it as a valuable sources for scholars and researchers. What do you mean by Diophantine equations? See, it is a polynomial equations in two or more variable with integral coefficients, and the solutions are also integrals. So Bhaskacharya, Siddhant Rishimani discuss about Diophantine equations in the section of algebra. There are some key points about this. So there are linear diploma, Diophantine, which solve the equations about linear equations. Quadratic Diophantine, he discussed about the quadratic equations and provide solving them. Intermediate equations, it also explain how to solve the intermediate equation which have the multiple solutions, including Diophantine equations. There is some method of continued fractions, and he used the method of continued fractions to solve Diophantine equations, which is a remarkable achievement considering the time period. And Bhaskacharya works on the Diophantine equations, demonstrate his mastery of algebraic method and his contribution to number theory. His method for solving Diophantine equations were well ahead of this time and had a significant impact on the development of number theory in India and beyond. So what do you mean by trigonometric equations? So trigonometric equations also define about the linear Diophantine equations, quadratic Diophantine equations, intermediate equations, method of continued fractions, and there is some different type of theoretical equations of this time and had the significant impact on the development of number theory in India and beyond.